Hi grade 9s, welcome back to another one of our lessons. So today we're going to continue with the congruency conditions. Okay, remember in the last lesson we covered the 4 different congruency conditions for proving 2 triangles to be congruent. I'll quickly run through those again to just remind you. So the first one was SSS and it stands for side, side, side. So if we match up 3 sides of a triangle to another 3 sides of another triangle and they are the same, it means the triangles are exactly identical. Okay, then the next two is side, angle, side, and angle, side, angle. Okay, what's interesting to note here is that the one of the letters is between the other two. So we have side, angle, side, and angle, side, angle. Okay, so the easy way to remember this is that there has to be an included side or an included angle wedged between the other two given sides or angles. So side, angle, side means that we need to have a given side, we need to have an angle in between that given side and another given side. Okay, so that's this one over here. An angle side angle means that we have to have an angle, we have to have a given side and another angle. Okay, so this side, that S, is wedged between the two known angles. And this angle is wedged between the two known sides. Okay, so that's these two conditions. And then the last one is RHS, which is right angle, hypotenuse, and a side, either one of the remaining two sides. Okay, so those were our 4 conditions for proving congruency in triangles. Now let's go look at more complicated example rather than exercise 13.6 in the previous worked example. So if we look at worked example on page 135, so it says AB and CD intersect at E with AE equals to EB and CE equals to ED. Okay, so let me draw the diagram first quickly, and then we can do it. So we have essentially 2 triangles that are kind of doing this, okay? And they say that this equals to that, and this equals to that, and we have A, B, C, D, and E. Okay, this is the diagram that they give us. Okay, so again, let's just read the information. A, B, and C, D intersect at E. There it is. With AE equals to EB, AE equals to EB, and DE equals to EC, or CE equals to ED. Okay, so that's the info they gave us. Now they're saying, 1, prove that triangle AEC is congruent to triangle BED. Okay, so when they ask us to prove something, we need to show whatever condition we are proving for congruency. So out of the 4 different conditions that we have, we need to pick the one that suits the information given. So let's run through them. Do we have all 3 given sides for a particular triangle? Sorry guys, it's very chilly today. It's actually too cold, but yeah. Anyway, so do we have the 3 sides for each triangle? No, they've only given us one side, another side, another side. So we only have 2 given sides that we can use, okay? This side AC and DB we know nothing about, okay? So we can't use those. So we can't use side, side, side. We also can't use right angle hypotenuse side because we don't have a single right angle in this diagram. So that falls away as well. Well, what else can we use? We can either use angle side angle or side angle side. Well, what do you notice here? I have a side, I have another side. These 2 sides also match up. And I've got these 2 angles over here. Can I prove that these 2 angles here are the same? Yes, I can, because remember, vertically opposite angles are equal. So this angle equals that angle, and that creates my condition for congruency because I have a side, included angle, and another side. And I can match those 3 things up exactly to those three things in the other triangle, hence proving that the two triangles are exactly the same. Right, now I'm going to show you how to set up this question. Right, so what we're going to say is that first we need to state in which triangles we are working. Okay, so I'm going to begin by saying in triangle A, so not D, AEC and triangle DEB. Okay. Now the order of letters doesn't really matter that much because you're just naming it in order. Okay, so we could have started with CEA, or we could have said EAC or ACE like I've done it here. Okay. Right, so AEC we go clockwise, and here DEB, let's also go clockwise. So I'll call this one DBE. All right. Right, now we stated in which triangles we are working. Now we need to start proving the congruency condition. Okay, so let's match up the sides that we know. Well, we know that AE equals to EB. What is the reason for us saying that? Well, it was given to us in the question. They told us in the beginning of the question that that's what the case was. So your reason is simply given. Okay. Right, we've shown that. Let's now show another side. So we have, or let's even do them in order. That would make even more sense. So now we're going to show that these two angles are the same. So we're going to say that angle AEC, okay, with the copy on the angle, so AEC equals to angle DEB. Okay, why are we saying this? Well, our reason is vertically opposite angles are equal. So vert op angles. Okay, vertically opposite angles. Cool. Now let's do the next piece. So we know also that CE equals to DE. Okay, what's the reason for saying that? Again, it was given to us in the question. So this is given. Right, now if you notice, we've met the three steps of proving that these two triangles are congruent. We showed that these two sides are the same, the two angles are the same, and this side is the same, and that is side, angle, side. Okay, and side, angle, side. So we're gonna, once we've proved the three things or the three conditions for whatever congruency condition we're proving, we're gonna say therefore triangle AEC is congruent, triple equal sign, to triangle DBE. Right? What is the reason for us saying that? Well, it's the proof that we proved. So we have to give the correct congruency condition, that, or rather the correct option for congruency. So that's exactly what we did here. So it's side, angle, side, which is side, angle, side, or SAS. Okay, and that is our reason for stating that these two are congruent. Okay, right, let's see what else they want. Now, number 2, they say prove that AC is parallel to DB. Okay, so they want us to prove that AC is parallel to DB. Okay, well, if these two triangles are congruent, okay, it means that, well, let's think. This angle here, which is between the long side of the triangle and this side of the triangle with 2 marks, okay? So this angle here, let me erase these two, is equal to, because remember, if we say the two triangles are congruent, it means they are exactly the same to each other, okay? So we can now match up the angles, because we can say that, well, this angle is the same as this angle, okay? Because it's between the line with 2 marks and the line with no marks. That's the same angle between the line with 2 marks and no marks. So this angle is the same as that angle. Okay, I'm going to take this off. Okay, so let's state that. Let's say angle ACE equals to angle EDB. Okay, why are we saying this? Why are they equal? Sorry, the copies. Well, they are equal because the two triangles are congruent. Okay, so that's what we're going to say. So we're going to say that triangle ACE is congruent to triangle DBE. Okay. All right, so that is our reason. Cool. We've shown that these two angles are the same. Now, can we state that these two lines are parallel? Yes, because this gives us our alternate angles. Remember, if the lines are parallel, this angle will be the same as that angle. So now we're just looking at it backwards. If the angles are the same, that means the lines are parallel. Okay, so we're going to say that, therefore, angle AC is parallel to DB. Okay. And we can say, well, we don't need to say anything because we've actually shown that the two angles are the same, therefore they are parallel. Okay. Let's see if they give us any reason. Okay, so there is a reason. There's equal alternate angles. So remember, going forward, we use alt angles, and you tell me which parallel lines we have. If we're going backwards and we show that the angles are the same, therefore the lines are parallel. So we state the lines are parallel, therefore the reason is equal alt angles. Okay, so equal alt angles, there they are. All right. Okay, cool. So let's now continue to number 3. Classify quadrilateral ACBE. All right, so quadrilateral ACBE. No, ACBD. Okay, so now they're joining it together. So AC, B, and D. Okay, so there's our quadrilateral. So we need to now figure out what kind of quadrilateral is this. Okay, so, well, let's think. We have two diagonals that are bisecting each other. Okay, so that's our first clue. Two diagonals bisecting each other. They're not telling us that they are all equal. Okay, if they are not all equal, meaning that this piece, that piece, and that piece, if they are not all equal, that means the figure is slanted onto its side. So this can't be a square or a rectangle because of this fact that they are not all the same. Also, they didn't give us any angles in terms of measurement. So they didn't say this is a 90 degree. So we cannot conclude that this is a 90 degree figure. Okay, so it's slanted onto its side. Right, so what could it be? It could be either a rhombus or a parallelogram. Okay. Well, for it to be a rhombus, we need to be given that all of these sides are the same. We are not given that information. We are not given any info about the sides being the same. But we also know that this line is parallel to that line, and also doing a Z like that will show that that angle equals to that, equal alt angles, meaning that these two lines are also parallel. So we've got parallel lines, they bisect each other. I would say this is a parallelogram. If they give us more info, we could reclassify it into a rhombus or something else. But the way it is, I would say it's a parallelogram. Okay. Right, so if we conclude that the shape is something, we need to give them a reason. Okay, so what is the reason for us for concluding that this is a parallelogram? Okay, so for number 3, we're going to say that A, B, C, D is a parallelogram. Okay, it's a mouthful. Okay, so ABCD is a parallelogram. What is our reason for it? Okay, so remember the easiest reason is that the diagonals bisect each other, not that they're all the same, but that they bisect each other. Yes, we could have also proved that the opposite sides are parallel. That could have also worked, but remember, we didn't have this as a proof. We have to still show it and then use that result. But if we use these diagonals, because these were all given to us, okay, so we can use the easier way to say why it's a parallelogram. And the reason is diagonals bisect each other. Okay, my terrible cursive handwriting, it says diagonals bisect each other. Okay, it actually looks terrible. I'm going to erase it. Okay, let's try again. Diagonals bisect each other. Okay, that's a little bit better. All right, cool, guys. So again, it's useful to know what are the different characteristics of each parallelogram, or rather, not a parallelogram, sorry, quadrilateral. And from that info, you have to pick out the one that will be the easiest way to say whatever classification this is. Okay. All right, guys, so that was the worked example. It was quite a long one, I understand, but guys, we have to set up the geometry questions like this, because your marks, when you do this, your marks are going to count for this and for that and that. So every statement you give me needs to have an accompanying reason. Why are you saying this? Okay, that's very important, guys. All right, let's look at exercise 13.7. Number one, state the 4 cases of congruency in abbreviated form. Okay, that's really easy. It's on the previous page. Number 2, refer to the sketches above and prove that the pairs of triangles are the same. So you guys need to use the information that is given in order to prove congruency between these conditions. Guys, there's something that we didn't, well, not that we didn't cover, but maybe you're not aware of. If we look at number 2, the second diagram in blue, okay, so this diagram over here, what we can see is that we have common lines there, and we have common, oh, I'm making a mess on the book. All right, we have common lines, but the triangle, the third line, is this line in the middle, okay? And both of the triangles share that same line. So that means it's the same for both. So you're going to say, if that's one of your statements in here, you're just going to say that AB is common. That's it. It doesn't require any reason or anything. It's just that it's a common line. It's the same for 2 figures. There's nothing more for us to say. Okay, so if we are looking at this triangle here, okay, and this triangle here, this line AB would be a common line, okay, or a common side between the 2 triangles. And when we prove the congruency, like for this question that I just showed you, you'll see that you're going to use the condition side, 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 and that's how you're going to prove congruency. All right, guys, I want you to work through exercise 13.7. Okay, it is a long exercise. It goes up to question 6. But the good thing is, it is Friday, it is a long weekend, and you guys have tons of time to do it. So I want you to do the whole exercise, which is exercise 13.7. And next week, we're going to begin this with similarity of triangles, okay? Those are not very difficult. They're quite quick. We'll do that, exercise 13.8, and we're going to finally get onto geometric problems. Alright guys, I hope you enjoyed the video. Please do that exercise, prove the congruencies, and we'll continue with similarities next time. Thank you.